Welcome to today's tutorial. Today I will be describing the features of our improved precursor ion quantification module in PEEX-8. In this video, I will discuss the improvements we've made to this labeling quantification option, which applies to such experiments as SILAC using data from this recent publication. PEEX-8 offers enhanced computational features, which ensures more accurate and reliable SILAC quantification results. Firstly, the algorithm has been improved such that PEEX-8 detects, highlights, and quantifies peptides at the feature level. Additionally, it provides more manual control for users, enabling the removal of peptides that are deemed to be less confident quantification candidates, an assessment that is based on characteristics of the feature vector labels. Finally, PEEX-8 employs a computational solution to correct for the problematic conversion of heavy free arginine to proline. Overall, this will provide improved reliability and confidence in the results from your analysis. SILAC quantification results can be generated by employing the easy-to-use workflow in PEEX, which can be initiated just by starting a new project. Select the New Project folder icon and add your raw data files from the Project Wizard screen. As PEEX-8 allows you to analyze individual as well as grouped raw data files, we recommend adding each raw data file as a separate sample, using the Multiple Beaker button. After you've added the data, simply choose your enzyme, instrument, and fragmentation option, and then move on through the workflow. While the workflow will take you through data refinement and identification, the focus of this tutorial will be on setting up a quantification project. For SILAC experiments, select Precursor Ion Quantification, choose your experimental method, and apply your chosen filters. We usually recommend setting a slightly wider mass error tolerance than you set for identification. You can then choose to group replicate data before you initiate your analysis. Finally, apply the R to P correction to ensure that peptides with divided heavy feature intensities are added together before PEEX calculates the peptide ratios. The PEEX-8 peptide view makes it very convenient for users to identify confident peptides. For each peptide, the view is divided into 4 quadrants: an MS2 scan, a survey scan, the LCMS view of the peptide's labeled features, and a pane that combines an extracted ion chromatogram with an isotopic distribution diagram. These 4 panes apply specifically to a selected peptide feature vector, which you'll see when you click the All Vectors button. Clicking All Vectors will generate a table which shows all the features identified. By default, the feature vector with the highest quality is initially chosen. Before examining your data, it's best to select an appropriate set of filters. To change the feature vector filters, select the Edit button in the second row of the filtration options to open the filtration window. Set a -10 log P threshold through the drop-down menu or by clicking the False Discovery Rate button. Choose a quality threshold, the score for which is based on a comparison between feature vector characteristics, which include mass-to-charge ratio and RT differences, XIC shape similarity, and feature intensities. Set average feature areas and a charge range. Finally, choose whether or not you only want to display peptide features that include a reference label, and additionally, the minimum number of labels that must be present. This reference label can be set within experiment settings at the top of the filtration options. You can also choose which proteins you want to filter from your display by selecting the Edit button in the third row of the filtration options to open the protein filtration window. Set protein significance scores by choosing either an appropriate significance threshold or by setting a Benjamini-Hochberg FDR. Being that significance scores are -10 log P scores as well, if you choose to set a threshold, we recommend setting it to a value of 20, as this corresponds to a p-value of 0.01. Select a protein fold change cutoff and choose the minimum number of peptides that you want to include. Additionally, choose to exclude variably modified peptides from quantification, and decide if you want to calculate significance scores using either the ANOVA or the PEEX-Q method. As mentioned, PEEX-8 SILAC quantification is heavily feature-based. The LCMS and XIC panes show you the characteristics of the feature vectors used in peptide quantification. The LCMS highlights and zooms in to where the feature vectors are located. The information displayed from the pop-up windows that appear when you scroll over the feature markers in this view is also displayed in the feature vector window. As such, PEEX-8 enables easier viewing of the labeled feature vector characteristics. Ultimately, the ratio of the quantified peptide is calculated using the average light and heavy labels of every identified feature vector. The ratio of the protein to which a peptide identifies is calculated from the ratio of the light and the heavy labels, where the labeled areas represent the sum of all peptide areas that were used in the analysis. PEAX8 allows users greater control to decide which peptides are used in protein quantification. If you identify a peptide that appears to be a poor choice in your quantification calculation, simply uncheck the peptide from the analysis. Select the Apply button, which is found in the filtration settings within the summary view, to incorporate this change. When you return to the quantification pane, the area values of the protein will now only reflect the sums of the remaining checkmarked peptides. Apart from the sample profile, the XIC also provides insight into how good of a candidate a certain peptide may be for quantification. An isotopic distribution diagram and an XIC for both labels is displayed in the bottom right pane of the peptide view. Feature vectors with well-aligned peaks and well-matching distributions are better candidates for quantification, while feature vectors with poorly aligned peaks and poorly matched distributions are less confident candidates. PEAX8 provides a computational correction for the problematic arginine to proline conversion in heavy labeled peptides. When the R2P correction is selected back in the quantification setup, the total intensity of the heavy feature label is recognized, as seen in the LCMS view, where two heavy regions are highlighted. PEAX8 will then sum the areas of the two heavy labels and display the combined value in the feature vector table. This ensures that the final ratio of the peptide's associated protein is not affected by any conversion of arginine. Overall, PEAX8 offers many improvements to the previous PEAX 7.5. This includes a used quantification workflow, multiple options for filtering your results, ratio calculations based on the areas of the labeled feature vectors, a better display that includes options for more control of what peptides you want to examine and include in the ratio calculations, and an accurate arginine to proline conversion correction. Thank you for listening. If you'd like to try PEAX-Q with your own data, you can request a demo at bioinfor.com. Also, subscribe to our channel to learn more about PEAX, complete software for proteomics.